of the most fascinating things to me is how through studies that you've done, as well as people like Graham Hancock, is that these ancient biblical myths and stories are now scientific studies.
Mm-hmm.
They're becoming real science.
We've got a new branch of geology called geomythology, which basically looks at archaic accounts, traditional accounts that have come down to us by whatever venue. Biblical, like you just mentioned, is, of course, a very rich source, but all kinds of myths have...
There's hundreds, right?
Oh, yeah, hundreds. If we're talking about floods, we've got at least several hundred that have accounts. Sir James Fraser was one of the first, I think, in his work, early 20th century, where he just collected a lot of the flood myths from around the world. And it's amazing the parallels. Usually, there have been ways that academics have been able to sidestep the implications of that by concocting a lot of very weird. Usually, it comes down to it was a local or regional flood that was bad, but it was nothing on a scale that would have been planetary. And then through the telling and retelling through generations, it just got blown out of proportion and exaggerated, and that would be the primary explanation. The people, though, that are concocting those kinds of explanations don't know anything about geology. They don't know anything about glaciology or paleohydrology or the kinds of subjects that would allow you to go into the field and actually observe firsthand these landscapes that are the byproduct.
That's the thing about this, right? Is that there's so many different studies like geology and glaciology,
yes,
and so many things. It's almost impossible for one person to have a comprehensive understanding of all those subjects.
Yes, that's
very
true.
Rare.
Yeah,
you are a unicorn.
Well, it's definitely an interdisciplinary study, and I basically call it catastrophism, catastrophist studies, and to be very knowledgeable in catastrophist studies, you have to know geology, you have to know some astronomy, you have to know some paleontology, you have to know some sedimentology, some stratigraphy, all of that. You have to know about impact geology. There's a lot of things. People have different things that they're obsessed with and like. That's my thing. I use all my spare time to study. I research, study, and then I'll look at studies that come out, or whether they're brand new or even older studies, and then I use those as guidelines, and I design field trips and things around that to go and like when I first started in visiting these floodlands of the Pacific Northwest, which is going to be mostly Washington, but also Oregon, Idaho, and Montana. I was using early papers that were written in the 1920s and 1930s by one of the pioneers of catastrophist flood geology, which was J. Harlen Bretz. So I had reprints of all of his papers, and I used those as kind of guidelines and followed in his footsteps as much as possible. And he was, of course, very much ostracized by the geological community back in the 20s and 30s, who were strictly grounded in very gradualist models. Uniformitarianism was what the dominant model of geological change was called. And it was the idea that and it's a powerful idea. The present is the key to the past. And you basically, in order to try to understand what happened in the past, you look at processes that are happening today that we can witness on a day-to-day or a year-to-year basis, and then we extrapolate backwards.
Right.
So the problem with that, though, is that it became entrenched dogma. And what that meant was that only processes that we're seeing today, in terms of scales and rates of change and magnitudes and things, anything beyond that was considered to be pseudoscience or science fiction-y, and so you couldn't talk about, giant floods. But, part of that goes back to the origins of geology, when you had, in the late 16, early 17, through the 1700s, the 18th century, you had this conflict between science and religion. And the literalists, say the biblical literalists, had a lot of political power before the scientific enlightenment. And so, what the bishops ruled and what Rome ruled about, what was accessible Then you had the breakaway with the Protestants, but they were pretty much the same way, very fundamentalist about taking the Bible literally, right? And so, and in that model, the Earth is only 6,000 or 7,000 years old, and that was one of the big conflicts in the early days of geology. As it become obvious to anybody who really started studying the strata of the Earth that it could not possibly be only 7,000 years old, and Grand Canyon is the ideal exemplification of that idea, because you've got, when geologists now can look and you can say, okay, you've got sandstone. Sandstone is formed obviously from sand, but that sand can be either sand on the beach or sand in the desert. If it's sand on the beach, it's being shaped by waves and water, right? If it's in the desert, it's being shaped by wind. And we can go and we can look at sand in the desert today and sand on the beach today, and we can look at the forms that it's being shaped into by the forces at work on it, and see they're very distinct and different. Well, and then you can go and look at sandstone rocks, and you'll see the same types of formations and things, and go, okay, well, that looks just like what we might see in a modern desert if we took a cross-section of a dune and looked at it, and there it is. Okay, so now you got sandstone. Now you got limestone. Limestone is going to be formed usually in a shallow marine environment. Okay, you might have a peat that forms shales. Okay, so shales come from like muddy material originally. You have mudstone that can become metamorphosized ultimately into shale, and then if that's further metamorphosized, it becomes slate. Right, metamorphic means it's been subject to heat and pressure. Well, you can look at all these different kind of rocks, and you might have an igneous rock. You might have a granite, which is a type of igneous rock that forms below the surface. You might have basalt, which is an igneous rock that forms outside of the surface. Now, where I go up there in eastern Washington, it's called the Columbia Basalt Plateau. And around 17 million years ago, there was a major wound in the surface of the Earth that's right now where the Yellowstone hotspot is. The mantle plume that comes up under Yellowstone caused tremendous outflowing of basaltic lavas that created this Columbia Basalt Plateau. Now, there was 10 million years of these.
This was 17 million years ago?
Between 17 million and maybe 7 or 8 million years ago.
Okay.
It finally pretty much stopped. The early flows were the most voluminous, and then it sort of declined in volume over the time. But you'll get a layer of basalt, and then if there's a stretch of time of a few thousand to tens of thousands of years, what happens is soil will form on there, vegetation will grow, you'll have trees and all of this, and then another layer of lava comes in and drowns that. Well, sandwiched in between those layers of basalt, you can find the evidence that there was this hiatus. You can find the remnants of seeds and branches and vegetation and stuff actually sandwiched between. So that will tell you that, okay, so there was a hiatus, and then that, say a forest was there, it was drowned by lava, and then that lava cooled, new soil formed, another forest grew, etc. And then you can go below it and you find ancient granites, right? Now you can go, and when you begin looking at the stratigraphy, you can see, okay, if you've got, let's say you've got a beach, right? And now the ocean rises. That's called a transgression. The ocean rises, and now that drowns the beach, and now you've got an ocean, say a marine environment over it. So now you get all of the creatures and things that live in that marine environment, the little creatures that form their shells out of calcium carbonate. They die and they drift to the bottom, and eventually they form thick layers of what is now limestone rock. And you can tell it's got fossils in it. You can tell that it was the calcium carbonate, because if you put acid on it, it'll bubble, right? So now if you have a beach, okay, the ocean rises. Now you have layers of limestone, right? So now if the beach recedes, as it's receding, maybe the swamps or the forests there will follow it, and then eventually you'll get a layer of shale. And then you see that succession repeats itself. Sandstone, limestone, shale. and then there might be more sandstones that you can tell that it was a
Right.
beach. So it goes through this whole cycle, and then it does that over and over again, you see. And you go, okay, this could not possibly, you couldn't get a layer of limestone 200 feet thick over a layer of sandstone that's just as thick, right, in 7,000 years. You can't do it.
Right.
So this was the conflict there that in the early days of geology. So coming back to J. Harlen Bretz and his studies on the great floodlands of the Pacific Northwest, the attitude was, hey, you're trying to take us back to biblical fundamentalism with your flood theories. We don't want to go there. So it took like 30 years before mainstream geology finally accepted that, yeah, Bretz's gigantic floods were real. And they really did happen. And they were on the scale that he was describing.